Okay, section 13.3, we're talking about geometric probability, and this is unit 13, because unit 13 is probability, but we talk about it in this unit because we are talking about the area of these different polygons, and so we do talk about this geometric probability here, and we actually don't really even teach unit 13, and so it really needs to be in this unit. And so what this first concept says is this is the length probability ratio. This says if a line segment 1 contains another segment 2, so basically you have this segment BC within this segment AD, then a point on segment 1, which is the red, is chosen at random, then the probability that that point is on segment 2 is. And so all this is saying is, all right, if you have a point somewhere on BC, okay, what is the probability that a point would be on BC? And so you would take what the length of BC is, and you would divide it by the whole thing, which would be AD. And this would get you a decimal. You would move the decimal over twice, and that would be your percentage. So same thing with this example. So if point E on AD is chosen at random, and E is on BC, so this is just the same thing. So if that point is E and it's on BC somewhere, the probability of that being chosen would be BC over the whole thing AD. The area, so if you want to kind of think about this, a way that might help you, this will help you with the next thing too, is that if you think about the part that you want, and if you divide it over the whole, then that can kind of help you set it up. And so with the next thing, when we're talking about area probability, this says if a region A, so this blue part, the blue rectangle, contains a region B, so the red circle, and point E in region A is chosen at random, then what's the probability that point E is in region B? Okay, so again, you want to take the part that you want, which would be, in this case, a point landing in B somewhere. So you take the part and you divide it by the whole. And so you'd get the area of the circle and you divide it by the area of the rectangle. Okay, so we're just going to do some of these examples. And yeah. So number 1 says point X is chosen at random on JM. Find the probability that X is on KL. So here the probability that the point is somewhere in that region. I'm going to take the part, which is 7. I'm going to divide it by the whole. And if you add all of those up, that's 14. If you type that in the calculator, it's 0.5. And so if you move the decimal over 2 times, then that would be 50%. Number 2 says the probability. When you see this P like that, that's saying the probability. It didn't say that up at the top, but that's what you would see. When you get into statistics, you'll see that a lot. So the probability that X is on GJ, so from G to J, I want that part. So if I take the part, that's 12 plus 14 is 26, over the whole, which would be 36, you end up getting, it's 0.722, and so that would be 72.2%. Okay, these are the ones where it starts to get a little bit trickier, but again, we're still just doing the same process. So find the probability of picking a point in the shaded region. Okay, and so it's telling us that these 4 triangles are congruent. Well, I've got 4 triangles here. So the part, there's 1 part to the whole, which is 4 parts. And so this would be 25%. This would be 0.25. Number 4, given the 2 squares, and it wants the area of just the shaded region. Okay, and so we're gonna get the area of the part that we want, and we're gonna divide it by the whole. Okay, so keep in mind the part that we want is just the shaded area. And so we need to get the area of just that part. Okay, we did this last time. Well, actually, same lesson today. It was 11.3, I think. But if I just want the area of that part, I would need to take the area of the big square, which would be 9 times 9 would be 81. The area of the small square would be 9. And so if I just want the shaded part, I would subtract those. And so the area of the shaded part would be 72. Okay, and so if I get the area of the shaded part, that's the part that I want, and I divide it by the whole. Okay, well, what is the whole here? The whole would be 9 times 9. That would be 81. And if you do 72 divided by 81, you'll end up with 88.9%. Number 5, again, just getting the probability of picking a point in the shaded region. Okay, and so here, again, we want to get the part that we want. Okay, well, the part that we want here is the circle, okay, because that's where the shaded part is. So I'm going to get the area of the circle. That's going to be pi r squared. Well, I'm just going to count these units here in this graph. So it'd be 1, 2, 3. So my radius is 3. So that would be pi 3 squared. So that'd be 9 pi. Okay, and then I need to get the area of the square, which would be, if I count 1, 2, 3, 4, 5, 6 by 6. So that'd be 6 times 6 is 36. So I'm going to take the part that I want, which is the 9 pi, and I'm going to divide it by the whole thing, which is 36. And if you do 9 pi divided by 36, you get 78.5%. Okay. Number 6, so given a trapezoid, okay, and I'm going to actually clear some of this over here. If you didn't get that, then just rewind. All right, so number 6, given a trapezoid, so we need to get the area of just the shaded region, okay? And so we need to get the area of the parts that we want. We're getting the probability of the shaded region. So I need to get the area of these two triangles, and then I need to divide it by all of it. Divide it by the whole. Okay? So let's first start and let's get the area of the triangles. So the area of the triangles, I need to do base times height divided by 2. Okay, well, I know the height of the triangles are 12. And then if this piece here is 14, then I know the other two sides of this are going to be 3 and 3, because that adds up to be 20. And so if I do base, which is 3, times height, that's 12, divided by 2, that gets me 18. Okay, but that's one triangle. And so I need 2 triangles. So both triangles would be 36. Okay, that's the area of just the shaded part. And then I'm going to eventually need to divide that. That's my part. I need to divide it by the whole. And so now we need to get the area of the trapezoid. So the area of the trapezoid. Okay, so I need to take the height, which is 12. I'm going to add the bases together. So that's 14 plus 20 and divide it by 2. Okay, so if you do that, you get, let's see what number that is. I think it's 204. Yep, so that's 204. So now I can take the part that was 36, that was the shaded part, divided by the whole, which is 204. And if I divide those, I get a probability of 17.6%. Okay, and then here we go. So here's just, some of these are easy. Some of them are a little bit more difficult, but I'm just going to do them all. So find the probability that the point chosen at random is in the shaded region. So this one's really easy because I have 9 blocks here that are all the same, 9 squares. Okay, so I've got 1, 2, 3. That's the part divided by the whole. So that would be 33.3%. Hardly any work to do there. Number 8, okay, I'm going to take the shaded part, which in this case is the square. Okay, so I need to figure out what the length of this square is. So if the radius is 2, that means this is a 4 by 4 square. Okay, so the area of the square is 16, 4 times 4. And then, so that's the whole square, but that's not the shaded part. So the shaded part here, I need to subtract out the circle. And the area of the circle would be pi r squared. So it'd be pi 2 squared, so that'd be 4 pi. So in this case, the shaded part would be 16 minus 4 pi. Okay, that would get me the shaded part. And now I need to divide it by the whole. And the whole would be the whole square, which would be 16. If you're going to type this all in the calculator at once, you've got to make sure that you group the top part together. If you want to be safe, just type in 16 minus 4 pi, press enter, and then divide by 16. And if you do that, you get 21.5%. Okay, and then number 9. And so here we need to get the area of the shaded part. Okay, so that's going to be the area of the triangle, which means I need to figure out what this piece is. I can actually look at this and I know it's a 30, 60, 90, even though it doesn't say that. But I can see that the hypotenuse is twice the leg that they give me. But we can go ahead and just do Pythagorean theorem just in case. So I'm going to have x squared plus 6 squared equals 12 squared. Actually, I'm going to go ahead and just change that to 36 so I don't have to waste space. So x squared plus 36 equals 144. So x squared, if I subtract 36, is 108. And if I take the square root of that, that would be 36 times 3. And so that leg would be 6 root 3. Okay, so now what we can do is we can get the area of the triangle. So it's going to be base times height. So it'll be 6 times 6 root 3 over 2. So the area of the triangle, that'll be 6 times 6 is 36 divided by 2 is 18 root 3. So that's the part that we want. Now we need the whole, okay, and the whole is going to be the circle. Okay, well the radius, or the diameter is 12, which means the radius is 6. So pi r squared, that would be 36 pi. So I'm going to take the shaded part that I want and divide it by the whole, which is 36 pi. And if you type that in the calculator, you get 27.6%. Voila. Alright, and then these last 3, I am just going to do, I will do number 10 and 12. How about that? Alright, so the probability again that it's in the shaded region. Okay, and so here, I need to get the area of the shaded part. Okay, so I'm going to look at these. There's a couple different ways you can think about these, the area of the shaded part. I can see that these are 4 right triangles. And I know you're looking at this like it's a big square, and it is. But I'm just going to think of this as 4 right triangles. And so if I want the area, I'm trying to think of the easiest way to explain this to y'all because there are multiple ways to do this one. I'm going to think, okay, well, if that's 4, this is 4. Okay, and this would be a 45, 45, 90, which means all these tick marks inside would be 4 root 2. Okay, because it's x, x, x root 2. And so if you want to get the area of just the shaded part, this is an 8 by 8 square here. So if I did the area of the square, the area of the big square, which would be 64, then I need to subtract out the area of the small square. Okay, the area of the small square, I'm going to write it up here, would be 4 root 2 times 4 root 2. So that would be 16 times square root of 2 times square root of 2 is 2. So 16 times 2 would be 32. So that is the area of the shaded part. If you wanted to go ahead and just simplify that, that would probably be best. So 64 minus 32 is 32. So that's the shaded part. And now we need the whole. So the whole would just be 8 times 8, which is 64. And 32 divided by 64, that would be 50%. Which makes sense. Kind of looks like it would be 50%. Let's just look at number 12. We don't have to work all the way through it. This is just realizing, this actually isn't that hard at all. This is just realizing, okay, well here if the radius is 3, that means the radius of all of these are 3. And so this is a 12 by, then you got to go this way with it. You don't have to draw all these in. I'm just doing it. So this direction, it would be 18. And so that's how you would start this. And you would get the area of the rectangle, subtract out the circles. Of course, there's 6 circles there. And that would get you the shaded part. And then you divide it by the whole, which is the rectangle. So not that bad.